Get rid of these and move them to the left. Everything stays in order. Okay, so this residual output, I'm just going to gray this out right now. And for a purpose, because it'll be important in just a few minutes, okay?
Mm-hmm.
So what I have to do is look through here. And all significance is reported at the 3 decimal level. So this is truly 0.039. So, Shonda, is this significant or not? How do we know it's significant or not?
Because it's not higher than the 0. It's the 0.5. No, the 0.05.
0.05 is exactly correct.
Okay.
So it's less than 0.05, right?
Mm-hmm.
It's actually 0.04, but I'm going to say it's 0.039 because, again, significance levels, alpha levels, p-values all get 3 decimals. Everything else gets reported to 2. Okay?
So this would not be significant.
Oh, it is.
Oh, it is significant. So if it
0.05 and under is significant.
Okay.
Okay? So I can look in here and I can write and just tell immediately this is significant. Because why? That makes sense?
Yes, it does.
It helps if I spell correctly too, huh? Alpha level. Okay? So let's go back up here. What is this multiple R 0.66?
I'm not sure. Is that gonna be the
What is the R? Do you know?
R is multiple, comparing multiple variables, right? The regression.
Yes, but it's not regression. This is correlation.
Okay.
So this is the correlational value. That's all it is.
Okay.
That makes sense.
Gotcha.
Okay. So R is the abbreviation for correlation. And it's not just R, it's lowercase. And it's also italicized. So R is the So the only difference here is that it's a capital R. That makes sense?
Yes.
So it truly is still the correlation value, but what is that R squared? So take 0.66 and multiply it times 0.66.
That's the square.
That's the square. That's exactly right. So this outcome is
the square root of R. Square value.
Square value is the percentage of the dependent variable, which is...
So that would be 43%.
typical the independent variable. Okay, so are you typing this into yours? You
No.
should be able to take this and save it on your desktop.
Okay.
Because once you have everything explained to you, it really does help make sense.
Mm-hmm. Well, I remember reading that. So that is the...
Exactly right.
Yeah, so the R square tells us that the hours of study at home can account for. Okay, I got you.
Okay, so in that instance, we turn the R squared into a percentage by multiplying it times what?
Moving the decimal 2 places. Multiplying by 100.
That's the same thing as
Mm-hmm.
moving it 2 places. So that's what we do. So this is really telling us now, come on, 0.432 per square tells us that 43.2% of the GPA is okay, so does that statement make sense?
Yes.
So look, that means that almost 57% is attributable to something else other than the hours of study at home. And because we're paying teachers and because we have a principal and because we work hard at what we do, I'm glad that it's only 43. But 43 is a big number.
Mm-hmm.
Does that make sense?
Yes.
So 43, that's something I have to make work for me. And technically, isn't 66.66, is that a strong correlation?
Yes.
Yeah.
Yes.
So if we remember back, hang on just a second, let me...
In correlations. That would be moderately strong, right?
Well,
moderate is 70.75.
No.
Or am I off?
This is what we did. So we had 1, we had 0, and we had -1, right?
Mm-hmm.
So somewhere about half was what?
0.5.
0. And then what would be right here?
0.25. 25. And 75.
And what would be down here?
75.
0.75.
Mm-hmm.
Okay, so and the same thing happens over here, except it's -0.5, -0.25, and -0.75 because it's to the left is 0, right?
Right.
So when we look at this, everything in here is what?
Weak.
And then, let me go get another color. So everything wet. So everything here is supposed to be green. Okay, so everything here and here from 0.25 to 0.50 and negative 0.25 to negative 0.50, what are those?
I must be missing something because the only thing else I'm thinking is moderate and strong. Oh, it's moderate.
Moderate is, that's right.
Okay.
Okay, so the only other thing left for us, go back to the pencil here, and I'll get blue, here we go. So you think about everything from 0.5 to 1, and everything from negative 0.5 to negative 1. What are those?
Strong.
That's what's left, right?
Right. So everything 0.5 and higher is a strong correlation.
Okay. And it's also strong over here on the negative side, right?
Mm-hmm.
So if that's the case, if you did like 0.52, that is moderately strong. But when it's 0.66, that puts it all the way up here somewhere. Oh, come on. That puts it up here somewhere. And that's not moderately strong, that is strong. If it was down here, it's really not that close to the moderate, so it is strong. So 0.66 is a strong outcome, and we need to keep that in mind because it takes a strong outcome in the correlation in order for it to be a good predictor. Okay?
Yes.
So you understand what these numbers are now?
Yes.
I got rid of everything but these three. Why did I keep observations at 10?
Because that's how many students we have.
Exactly. And this is telling me I got them all.
Mm-hmm.
So this is not there for anything in terms of knowing or interpreting. It just tells me I got all my data.
Okay.
That makes sense?
Yes.
And I wouldn't look at this unless, I really came up with some weird numbers. But the 10 tells me I got everything.
Okay.
Well, the degrees of freedom, DF, tells me the same thing. So I have 1 plus 9, and that gives me 10. So the formula for calculating the degrees of freedom is always 10. Is n minus 1. N is your n count. The n count here is 10 students. Right? That makes sense? So there's my 10, and 10 minus 1 is going to tell me 9.
So we should always have a 1 right there in regression under DF.
For a simple regression, yes, ma'am.
Okay.
But if we have multiple regression, that number changes.
Okay.
But this number and the bottom number are going to come back and tell me this is it. Okay, so now we understand what 0.05 means, right?
Yes.
Significance and lower. So the 0.05 itself, we talked about this in class while you were there earlier. It means that 95 times out of 100, these results are dependable and reliable, and we can get the same results 95 times out of 100, right?
Right.
And why not 100 times 100?
Because it's not.
Because where did this data come from over here?
Out of the book.
From kids, from people.
Yeah.
Yeah, that's where it came from, out of the book. But the data represents people, and people
are not going to be the same. Yeah.
Or they might exaggerate how many hours they study at home. That makes sense?
Yes.
So we keep that 95 0.05 as our alpha level. So, this tells me the overall model has a significant factor here. Now, I look down here in the coefficients table, and I see intercept and hours of study. So, what is intercept actually in this case?
GPA.
GPA. So I'm just going to wipe this out and put in GPA and hours of study.
Mm-hmm.
So, what is this supposed to be reported to? 2 places.
So 1.91.
It should be 2 places. Okay. So before I look at these numbers in actuality, I want to make sure that my p-values significant is good in all instances. So this number is actually the same, isn't it?
Yes. The significance of, yes.
So the 109 is identical, and it should be, because it is the one and only predictor variable. So I could write over here, IV is the predictor variable. Again, folks, if you right. So the DV is the outcome variable. Okay, so in here, GPA. So is that the dependent variable or independent variable?
GPA would be the dependent.
Very good. Tell me why.
Because it's not going to change. No, yeah, the grade is not going to change. We're looking at the different hours of study. So
Yes.
the hours are changing.
But the GPA is what we're hoping to increase.
Mm-hmm.
To increase it based on the relationship between the GPA and the
hours of study.
So as one goes up, we hope they both go up. That makes sense?
Yes.
I wouldn't want the hours of study to go up and the GPA to go down. And I wouldn't want the GPA to go up if the hours of study at home go down. That makes sense?
Yes.
So the dependent variable is what we're hoping to move up, and what can we manipulate? The independent variable, and that is the number of hours studied at home. So we're using the hours of study to predict what the GPA will be. Does that make sense?
Yes.
So, this was literally the same as this. That tells me it's significant. Well, what about the other outcome variable? Oh, it's significant too. So I have really good confidence in this regression and regression model. Well, that's another thing I need to teach you how. Regression model. So that is nothing more than taking the data from right here and applying it. So let's look at what those real numbers are. 1.91. And what is this, by the way? 1.91 what?
That's the coefficients of the GPA, of the
GPA.
dependent variable.
So what is a GPA of 1.91? It's not a C. It takes a 2.0 to have a C. So that's a high D.
Okay.
So all that tells us is that the kid Joe average student at this school makes a D plus with 0 hours of study at home. 0.
Okay.
That makes sense?
Yes.
So that's how we put these together. And it's at a significant level, so we have good faith in this starting point. Now, what is the 0.28?
That's
What is that?
That's the coefficients for the hour of study. So does that mean that they're only studying 28% of an hour? Like, what is that?
So that 0.28 it's still measuring in GPAs,
Okay.
grade points. So it's to tell us that for every 1 hour, 1 unit of study, that grade point is going to rise by 0.28 of a GPA point.
Okay.
Does that make sense?
Yes.
So, trying to open up my calculator. So, a kid who has just 1 hour of study at home is going to have 1.91 plus for 1 hour and have 0.28 GPA because there was only 1, right?
Right.
Are you with me so far?
Yes.
So 1 time 1.91 plus 0.28 is now 2.19 GPA. Well, that got him up into the C range, right?
Right.
Can we see? A lot of kids live with a C. But that's just 1 hour of study at home. You with me?
Right.
Well, what if there's more 1? What if I have this great confidence in this and I have a conversation with Mom and I say, Mom, you know, Junior there has a grade point average of 1.91. Freshman year, first quarter. I say, but I've done the research and I know from running a regression on a lot of students that we expect that 1.91, but did you know that for every hour of study that he does at home every week,
increase by 1 point, it could increase by 2.28. Yes.
That's over a quarter of a grade point, right? So that's all good. But what happens, Mom, if I ask you to look at him one night on Monday, one night on Tuesday, 1 hour. 1 hour on Monday, 1 hour on Tuesday. Look, I know you go to church on Wednesday, so we're not even going to do that. But what about Thursday? We can get 3 there and just 1 more. And it doesn't have to be on Friday. It can be on Saturday. It can be on Sunday. It's really up to you and him. But that 4th hour does what? That 4th hour gives...
The 4th hour will take us over an entire point.
Yes. So 0.28 times 4. And we get 1.21. So here I'm going to rewrite this regression model. 1.91 plus. Now the number changed to 1.12, which was 4 units. And that now equals, come on.
3.03. Yay, I did it in my head.
So think about that. 4 hours of study per week results in what? Them going
from a D to a B.
You think parents are going to buy into that?
Yes.
All day long. They're going to treat school like Tunica. They're going to push all their chips in.
Yes.
They're going to say, you know. And as a principal, look, I had 7 through 12 kids. And my 7th graders and some of the 8th graders, they didn't think they needed to do homework. They would go home, they would get on the 4-wheeler, and they would ride out in the woods forever until it was dark 30, time to come inside and eat dinner, get a shower, and go to bed. Well, where did homework fit in there? Oh, it didn't. So I didn't use a regression model. I didn't think to. But I did hold those kids accountable. If you didn't turn in your homework, and Miss Wheeler told me you weren't turning in your homework, I got out a paddle. And I set the paddle in front of them and said, look, tomorrow morning, when you get off the bus, in your left hand, you're going to have your homework for tonight and the homework you missed last night. Because you can't pass our class without doing homework. And they would all say, yes, sir. I said, but this is what you need to know. That paddle is going to get applied to you if you come off of that bus and those papers are not in your left hand shaking and waving at me. You will get off that bus and you will follow me right to this office, and I will tell you to put your hands in that chair, and I'm going to light you up. You see,
Right.
I wasn't playing around. I knew the impact of what was going on or not going on at home. That makes sense? So, oh my goodness, I wish I'd been able to put it into a regression model and be able to talk with mom in a very different, but look, I mean, when I called mom and she said, you know, well, yes, sir, he comes home and he does a couple of chores that his dad has for him and gets on his 4-wheeler and goes and rides. I said, do you check his homework? Well, I asked him. He always tells me he doesn't have any. And I said, well, would you believe he lied to you? And, well, not every parent wants to believe that. Anyway, mom would see it, because at that point in time, I had to have mom sign off. She had to give me a signature in the lower right-hand corner of every paper that he was to give to Miss Wheeler. Well, you know, that got right to the point. And, you know, well, let's put it this way. There were a few boys who didn't have it in their right hand.
Mm-hmm.
And when I took them to the office and I lit them up, I didn't get repeat business.
Right.
Because they didn't want to be back in that office because Mr. Bunch's shoulder, his arm was way too well developed, you know, not to go back. If I go back, he's going to clean me clear off the floor. So the point is, doesn't this make far more sense, being able to have a conversation with the parent instead of just telling them you're gonna paddle them tomorrow morning?
Right.
Now look, I had some moms who were telling me, oh, I want you to paddle him every day. You get him every day because, you know, he does stuff around here he's not supposed to, and he knows it. I'm not trying to be dad, but I am trying to be an accountability partner, and this lets me do that. Okay, so sorry to get off on a sidebar.
No, you're fine,
So
because
this
I'm actually
residual-
enjoying it. I'm enjoying it because
So
go ahead.
No, I just don't want to waste your time.
Okay.
So this residual output table, it's generated just by clicking a button, and what it does, it predicts what the GPA should be for that kid. But that's what the regression model is, right? This is a prediction. So when I say for 1 hour, and this is the predicted, what, GPA? 5. Yay. That makes sense?
Yes.
So again, go back and have that 1 for 1.91 plus. Now, this is the way I would have to write it. 0.28, 0.28 times x. And that's going to equal, what in the world do you have done there? Times x, and that's going to equal my predicted GPA. That is a regression model.
Mm-hmm.
All it is an algebraic expression, and what do I have to plug in? What do I not have in my regression model?
The hours of study.
Yes, ma'am, perfect. So I really can go up here and get these hours.
Mm-hmm.
Just copy those and I'll write them down so I don't have to go back and forth. So there are the hours. Well, what happens with that kid for 6? That's 1.91 plus, what is 6 times 0.28?
Oh, Lord.
1.68. And that equals
3.59.
okay. So think about that. The kid who up here has a 6-hour habit of studying at home, what's he supposed to generate?
Oh, and and he has 3.6, so he is on track.
He's so close on track, it's not funny.
It rounds to 3.6.
Well, and see, that's just it. This isn't rounding. It uses every bit of, it didn't round any of the coefficient or the hours. All of those numbers are being used.
Right.
So we round it off and it comes just a little bit short, but look at that kid. So see the negative number?
Right.
That's telling it that this kid actually underperformed, did not quite make what he was supposed to. And he made a 3.5 when he was supposed to make a 3.59. So he was under by 0.09.
Okay.
And that's what the negative is. So this kid was under